Hi, today we're going to look at negative indices. And the first thing I want you to do in a minute is pause this video and use your calculator to investigate the power button. And most importantly, I want you to put some negative numbers. I'd go with whole numbers, but you can play around with it and see what you get. So have a go now. Okay, so hopefully you've tried this. Here's one that I've had a go at. So I've put in 8 to the power of minus 1. How have I done that? I've written 8 and then this little button here that you see me indicating. And then you can either write the minus here, or this little minus sort of also means, it means like a negative number rather than subtracting, but either of those should work. And then I get 1 over 8. If I do the same for 5, to the minus 1, I get 1 over 5. So that makes us think maybe x to the minus 1 is 1 over x. Like this, we don't really have, understanding of why this is, but we can see this is what's going on the calculator. That's me conjecturing it. If I try it for say 12 to the power of minus 1, yes, 1 over 12. It seems to be working. Well, what if we try some other numbers? Let's say 2 to the power of minus 2. What does that give? This time it's not 1 over 2, it's 1 over 4. Okay, just going to think about that one for a minute. 3 to the power of minus 2 is 1 over 9. Now we know that 3 squared is 9, and we know that 2 squared is 4, so it seems to be that we're squaring the number and then we're doing 1 over it. So I'm going to sort of, make another little conjecture that x to the minus 2 is 1 over x squared. And we can test that. We can use a calculator again. Let's try 4 to the minus 2. So if I'm correct, we should square it to give 16 and then do 1 over 16. Yes, it seems to work. I wonder if x to the power of minus n is 1 over x to the n, because that seems to be what's going on with the pattern. So if that is the case, then I would expect 2 to the minus 3 to be 1 over 2 cubed, or 1 over 8. I can test that out, my conjecture. 2 to the power of minus 3, 1 over 8, done. And this result does stand. Okay, so please make a note of it. A negative indice basically means you just do 1 over it and then you still do x to the power of whatever it was. Okay, if there's a 1, it stays as x to the power of 1, which we don't normally write the 1. If it's a 2, it's 1 over x squared. Once you've got this general one though, then you've got all of them that you need. Okay, now let's try and figure out why that is true. We're going to look at some different expressions, first of all as fractions and then as indices. So when I've got fractions, say I've got 2 over 4, I can divide top and bottom by 2 to make it a half. I can do the same here with x to the 5 over x to the 6. I can divide top and bottom by x to the 5, and that would give me 1 at the top and x at the bottom. So x to the 5 over x to the 6 is 1 over x. Similarly for this one, I can divide through top and bottom by x squared. The top becomes 1, the bottom becomes x squared. I'm leaving it as a fraction. And this one here, x cubed divided by x cubed, well, I can either divide top and bottom by x cubed to give me 1 over 1, or I can just see that actually I'm dividing something by itself. That's going to give me 1. Okay, we're going to do the same questions now, but we're going to use our knowledge of indices. When I am dividing two powers like that have the same base, x and x, what I do is I subtract the powers. So in this case, I'm going to do 5 minus 6. I'm going to get x to the minus 1. If I do the same here, I subtract them, I'm going to get x to the minus 2. And here, I'm going to get x to the 0. And what we see is this thing here is the same as this thing here, x to the 5 divided by x to the 6. So it must be, if we accept the rules of indices and we accept how to simplify fractions, it must be that 1 over x is x to the minus 1. I know we've already said that from our calculator, but this is me demonstrating why. As long as we accept the rules of indices and we accept fractions, it must be true. The same goes for 1 over x squared is x to the minus 2. And actually, the same will follow in general, this most general rule, x to the minus n is 1 over x to the n. So we can see it working. Now, I see people accept this and use it, and then a few lessons later, they've forgotten what this negative means. You must remember that it means 1 over, okay, because it comes up all over the place. Negative indices are incredibly useful. The bonus one, just to talk about, is that x to the 0 is equal to 1. So that's something to be aware of. Something to the power of 0 is basically always 1. And again, it's followed from us understanding fractions and understanding the rules of indices. Okay, going to take it a little bit further then. So I've got a number line here, just a normal number line going from minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7. And then I'm finding the value of 2 to the power of n. So under here, it's 2 to the power of minus 3, and that's 1 over 2 cubed, or 1 over 8. Then we get 1 over 4, then we get 1 over 2, then we get our 1, because it's 2 to the power 0, and then it becomes a bit more normal that we're used to. 2 to the power 1, 2 squared, 2 cubed. And what is going on is that we are multiplying by 2 every time. Every time n increases by 1, I'm actually multiplying by 2. And I give this just to demonstrate a little bit more why this makes sense. Why does it make sense to have a negative indice? We know when we lower the power by 1, we're dividing by 2. If we just keep going, these negative indices just exist. There's nothing wrong with them. Okay, what I would like you to do is pick another number, not 2, but maybe 3 to the n, and try this yourself. So, you don't have to pick 3 to the n, you can pick anything you like, but go from n to minus 3 to 7, okay, with your number line, and then calculate without a calculator the values of 3 to the n. So 3 to the power of minus 3 is 1 over 3 cubed. It's going to be 1 over 27. This is me having a go at it, and so on. Have a go at this, fill in your number line, and then check it with a calculator. See if you are correct. Okay, hopefully you checked with your calculator and you're happy with this and you understand now the relationship between powers a little bit better and negative powers. That's the aim of this lesson, and this is the most important bit of the lesson. I know we're working algebraically, but if you've got this, you can do it for any number. The last thing I'm going to do then is just talk about a few more examples just to kind of get these. I would like you to write these down, make a note of them. And this is the sort of thing you need to be able to do, basically. This is like stepping up indices a little bit. We should know we should know basic powers of 2 and 3 and 4 and be able to deal with that. We should know square roots. This now is like extending it to negatives, and we're going to see that actually square roots are related. We can write a square root as something to the power of something. That's going to be coming up soon. This is like the step that you need to have to be able to deal with more complicated problems. So I'm going to be asking you, like in a few lessons, maybe next lesson, to tell me what 9 to the power of minus a half is without a calculator. So not only have I got negatives, which we've understood, we need to understand fractions as well. But that's coming up. The first thing is, let's get through these indices. So 9 to the power 0 is just 1. It's always 1. 8 to the power 0 is 1, and so forth. 7 to the power minus 1, 1 over 7. I do urge you, by the way, to pause this video and have a go at these yourself, just to check. If you can do them, and then you check with my answers and they're correct, then you can be pretty confident you've understood this. Okay, 6 to the power of minus 2. I'm going to take my time. I'm going to write the 1 over, then I'm going to put the 6 squared in. So this is what the negative is doing. And then it becomes 1 over 36. Same with 10 to the minus 2. It's going to be 1 over 10 squared, 1 over 100. Okay, we can check these with the calculator, but I am correct here. Okay, we're stepping up now. We're using the rules of indices, but with negatives involved, and then we're going to calculate what we get at the end. So 3 squared times 3 to the minus 5. Could work these out individually. No need. Let's use our knowledge of rules of indices. We're going to add the powers. 2 plus minus 5 is minus 3, so it's going to be 3 to the minus 3. I'm running out of space here, so I'm going to go straight for it. It's going to be 1 over 3 cubed, or 1 over 27. Actually, I think I did that one over here, didn't I? Okay, 4 squared divided by 4 to the minus 1. Rules of indices still work. It's going to be 4 to the 2 minus minus 1. Okay, I'm subtracting a negative, so actually it's going to become 4 to the 3, which is 64. Another way of thinking about this is that I'm doing 4 squared divided by 1 over 4. I'm dividing by a fraction. It's the same as changing it to a times and then flipping it. 4 over 1. Okay, so that's another way of thinking about it. But the rules of indices is where we're focusing here. Okay, 2 more. Same is going to apply. We're going to use the rules of indices. For this one, we multiply these two numbers. This becomes 2 to the minus 2, which is 1 over 4. And I can get negative indices to the power of a negative indices. And again, I just multiply these two. That's going to become 2 squared, actually, which is just 4. So hopefully those make sense. We've talked about these, I've given 4 more examples, and then I've extended it and just talked about the rules of indices here. Okay, so what I would like to do is have a go at these questions here. This will just check whether you've understood what we've done. So without a calculator, really important. Yes, you can check it into your calculator to get the answer, but it won't make, if it doesn't make sense, it's meaningless, isn't it? And this is a skill that you need to be able to do without a calculator. Because we're using all these rules, and I could ask it in such a way that you can't, a calculator wouldn't benefit you if I start using x's and so forth. You can't put that into your calculator. As an extension, I want you to investigate raising numbers, that should be numbers, to fractional powers. So that's like my 9 to the power of a half or 9 to the power of a minus a half. Can you figure out what is going on? We'll talk about that in an upcoming lesson on that, and again show why it's true. It's important to understand why things are true. It helps you remember it, and for me it's quite rewarding understanding why maths work. It's definitely not just learning a set of random rules. Maths is the most logical subject there is, apart from logic maybe, but maths is based upon logic. So have a go at that. I'm going to show you the answers now. So you pause the video and then check your answers to see if you are correct. Okay, what I meant was unpause the video to check if you're correct. So here we are, 1 to 28. I'm not going to talk about investigating fractional powers. The answer to that, you can send me what you think the answer is, but hopefully you are happy with this and you're ready to move on with your indices. Well done.